everyone. Welcome back. So, I know that today's topic is a little new for the channel, but this channel is supposed to be about science, and I am going to slowly start incorporating other forms of science, not just astronomy. So, be on the lookout for that. And if you're interested in joining any of the topics, you can just go ahead and join the Discord. That is where we have all of our chats. And I might not be doing that much talking because my voice is just starting to come back. But we are going to have a pretty good chat tonight, so stick around.
Okay, I'll go ahead and can you guys see my screen?
Yes.
Okay, let me go to the slideshow. Okay. So I'm ready whenever you are, Dan.
Yep.
And
Go ahead.
All right, yeah. So good afternoon or good evening, everyone. So my name is Mordwand. I am a statistician and applied mathematician. I work on various modeling problems in industry. I know a little bit about wave mechanics, but I can maybe comment more today on the statistical side of things. Um, and yeah, topic today is just rogue waves. The image here, while often described as a tsunami, is probably better understood as a rogue wave. So yeah, that's basically it from my side. We'll talk about what they are. We'll give some video examples, and then uh, we'll dive into some of the theory. And you can go ahead, Dan.
Yeah, you want to share your screen again, by the way, because you closed it.
I did.
My name's Dano. I'm from the channel Unfornicated. I served in the Navy as a cryptologist, stationed aboard the USS Kitty Hawk. Have a bit of experience being deployed. I've sailed over all four corners of the Pacific and the Indian Oceans, and I've seen some interesting things. And rogue waves are just some of those interesting sailor lures that were always hard to get anyone to take seriously, and come to find out that science actually found out about it and was able to put it. I'm glad to have this discussion today.
Great. Okay, so we can go ahead and dive in. You guys still, I refreshed the screen share. I don't think the slideshow works with the Discord screen share, unfortunately, but so as Dan kind of said, we're talking today about rogue waves, and the first thing to talk about is significant wave height, which I have the mathematical definition for. And the other thing is, as far as I understand it, correct me if I'm wrong here, Dan, but when we talk about rogue waves, we're really talking about wind and current driven waves, and ones that are like outside of the context of like some crazy bay in like Navarre, Portugal, where there's a focusing effect. Like
Right.
these are like, waves that are happening typically out in the open ocean or form in the open ocean and then hit areas that don't have that sort of like coastal forcing. Um,
Correct.
so yeah, the significant wave height is defined as the average height of the top third of waves. And a rogue wave is defined many different ways, but the commonly given definition is a wave of at least twice the significant wave height. Presented some photos here to show a few examples. The one on the bottom left is perhaps the best example, where you could just see that we have a singular wave on that just kind of pops out of the remaining wave field. I guess, Dan, do you mind giving us a kind of overview of what it's like to be in rough seas and how these things are sort of like experienced? Not just necessarily rogue waves, but
Sure. So I was on an aircraft carrier, so obviously it's the biggest military ship that we possibly have. Um, and the interesting thing about being in the middle of the ocean is that all you have is the horizon. So it is you out there. And one of the things that the Navy specifically teaches is damage control. Because if there's a fire on board, there's no place to run. You can't just surround and drown it, because then you cause flooding and the ship sinks. Um, Everything is based off of you are solely contained. You rely on everybody to do their job, and then some. Your life is in everybody else's hands because you can call for help, but it's going to take a while to get out there. The other thing to kind of mention is scale. You are a very, very, very tiny dot in a very big, wide open ocean. So even as an aircraft carrier, and that scale it becomes the first time out on flight deck, it becomes very apparent, and it can get overwhelming at times because you're out there for up to a month or so without seeing land. So it gets to be kind of you find comfort in the individual tasks that you have and your routines. But in the off chance you do be able to get outside and see a sunrise, see a sunset, um, watch us skirt a storm, because we won't even sail through a storm. Like if there's a cyclone, we will try to skirt it as much as possible, as much as our operations allow, because not even an aircraft carrier wants to go through the middle of these. So world waves are it's something that everyone always talks about, but it's always something that, it's always in the back of your mind. But luckily, they're not exactly very prevalent. So it's not something you have to worry about per se.
Gotcha. And let's just one sec here. Hello, I just plugged in my headset.
Yep.
Sorry. Okay. So I just want to show you what one of these looks like. So there's a number of different videos, but this one seemed to be pretty decent as to like what the experience is like. So I'll go ahead and play this, and then Dan, if you maybe want to, we can comment on it after it's finished. So it's pretty short. So you can see the significant wave height there, and just like the background of the sea.
Shit.
All right, well, there it is. So yeah, I guess, did you ever see a wave like relatively that size? And one of the things that there was a comment that kind of stuck with me from the video was that, if you see a wave in the video, like if you can point it out, if it looks big, then it's really big.
Yeah. So sailors have these things we call sea states, and what it is, it's a number scale. Usually it's between 0 and 5 or 0 and 10, and it basically talks about what the average wave height is around you. So it could be calm, which is sea state 0, which is glassy, to the upper number where you're talking about um, 10 to 15 to higher meter waves that are the average. So I've personally been in a sea state of the highest number outside of a cyclone, where we're talking about easily, well, maybe not as high, maybe it was a step down, like sea state 3 or 4, where we're talking easily 20-foot waves, a ship the size of an aircraft carrier doing 15-degree lists to the left or the right. You
Wow.
can feel it rocking up and down. Like if we're trying to do flight ops, I've seen what I would classify as a rogue wave, because it was basically a pretty easy sea state. It's a little choppy, but it wasn't too much. But we happened to be standing on top of the flight deck at the bow, getting ready to do what we call FOD, walk down, foreign object damage. So basically, hands in your float coat, and you're walking the entire length of the flight deck looking for foreign objects that could foul a jet engine. So we do that constantly. So if you're on the flight deck, you get up there, and it's a nice way to get some sunshine and stuff like that. And I remember standing on the bow, feeling the ship vibrate underneath our feet, hearing the loud bang, and all of a sudden getting sprayed over us because because it had hit the ship at just below the flight deck as it crashed through it, and we could feel it lurch up and everything else. So it was enough to kind of nervously laugh about with your friends next to you, but at the same time, you're like, "Can we get this over with so I can get down below?" But dealing with the sea states, it's like that's your average, and then so even if you are in a high sea state, and like your definition said, it's 2 to 3 times higher what the average sea state is. So if you're at the highest sea state and it's 15 meters, you're talking going from a 40-foot wave to a 120-foot wave.
Yeah, that's crazy. Yeah, and that's a good lead in to some of these historical rogue waves. So
Mhm.
I will just admit I got these from Wikipedia. I did try to vet them as much as possible, but just um, kind of disclaimer there. But yeah, so I think the thing here is that Dan, is that we did have captains, and I think it's important for people to realize that a lot of times when we're talking about the age of sail and into the present day, I think that there's some perception of like old seamen's tales and stuff, but
Mhm.
especially like captains of expedition ships or Her Majesty's royal ships, like they were extremely credible witnesses of the time, right? I mean,
Mhm.
they typically didn't put things in the log unless they had vetted it and it was sort of true, right?
Right. So
But
it's of note. You have an officer of the deck who, it's not always the captain. It's an officer of the deck who's maintaining while the captain sleeps or whatever. So what goes in the log is basically law.
I see.
Think of it that way.
Okay. Yeah, and so we had for centuries reports of rogue waves, but up until very recently, they were thought to be impossible by scientists. We'll talk a little bit more as to why that's the case. But the other factor here is that, especially during the age of sail, well, if you got hit with a 100-foot wave, well, the ship probably wasn't surviving that. That being said, there's a few notable historic waves where we do have some more measurements and observations. Interestingly enough, Columbus, his ship reported one, seeing one as tall as the masts of the ships. And at that time, Dan, that would translate to what, like a 60 or 70-foot wave, probably, or even higher.
Yeah. Yeah.
This one is interesting. And these are another one where we have, even though it's like somewhat anecdotal reports, if there was damage reported by water, well, we know the water hit that spot, right? It didn't get damaged by itself. And this one, it was striking to me that the lighthouse of Eagle Island was struck by a wave that ran up 100 feet of land and did damage to an area 84 feet tall of the structure, actually rendered the lighthouse mechanism. And I don't know if you guys have ever been to an old lighthouse, but when we're talking about one of these lighthouse towers that was damaged, and like especially the structure of the light itself, I mean, this thing is like the size of your living room. It's like the size of like a truck. I mean, it's this massive structure that would like often float on a pool of mercury, has all this mechanical structure. So for that to be rendered inoperable, 84 feet up the structure is remarkable. 1933, we have the USS Ramapo, an oiler, reporting a 112-foot rogue wave, supposedly recorded by triangulation. Then this last one is interesting, and I included it just because, the Edmund Fitzgerald, the song, it's a cultural thing. But there's an event on the Great Lakes called the Three Sisters, which is believed to be a rogue wave phenomena. And based on the size and the fact that the Edmund Fitzgerald kind of suddenly disappeared, it's long been suspected that a rogue wave was responsible. So Dan, I don't know if you have anything else to add here, but
Yeah.
this is just kind of an interesting history. I tried to space it out prior to the first scientific documentation.
So, just for a point of reference, the USS Ramapo is what we call a replenishment oiler or an oiler. So it's relatively sits lower in the water, has obviously it's filled with liquid and stuff like that. So that's not exactly an aircraft carrier. It's what fuels aircraft carriers. Still decent sized ships, don't get me wrong. But also to expand real quick on those, there's actually two other ones that I know of, and but they were mostly wave driven, but they still fit the rogue wave description. Um, in 1995, the Queen Elizabeth II encountered a 90-foot wave during Hurricane Luis in the North Atlantic. In fact, the captain even described it as that it came out of the darkness and it looked like the White Cliffs of Dover. Also in 1998, in the Sydney to Hobart yacht race, a 120-foot wave was documented in the Tasman Sea by a rescue helicopter during a storm, and that was the end of 1998. That was actually the end of my enlistment. So that was something that I was mostly um, aware of.
And let's just put this in perspective, because I think as much as it sounds huge that a 100-foot wave hit, it would be unfathomably huge if you saw it in person, right? Like it would look
Right.
like you were getting hit by a skyscraper size wave almost on the ocean. Like in an
Right.
aircraft carrier, how tall is the flight deck?
So if anyone's been to like the Intrepid in New York or the was it the Midway in San Diego or the Ranger in San Diego, the flight deck, a carrier that's fully laden with ships or I'm sorry, with planes and fuel and stuff like that, it sits at a roughly 60 feet above water, and it has a draft of 35 feet below water. And then the bridge is basically 150 feet tall. So that means that the bridge is roughly 200 feet above the water line.
So a 100 foot
So
wave, then, if it were to strike, and I mean, I'm trying to think with the draft and everything, but it's reasonable to say that it would pretty much sweep over the flight deck and
absolutely.
probably have enough force to like knock aircraft off if it were to strike something that size.
Right. So the aircraft are chained down with multiple chains. So the idea is hopefully we wouldn't lose any, but yeah, you're going to lose the equipment on there, and the equipment could also, because we have cranes and other vehicles that are on the flight deck. So those will probably end up causing damage too, and could dislodge the planes by breaking chains and stuff like that too. So yeah, the idea would be you hopefully wouldn't do that. That's why they chain them down that way as the ship's moving. But when you talk about the sheer power of the ocean, no guarantees.
Totally. Great. So I'm going to go ahead. Thanks for adding to that description there, Dan. So we had seen these sorts of events many times. I'm not sure exactly why it was that oceanographers and scientists were, disputing their existence. Maybe there's like a certain level of friction between industry and academia, as we often see. But in 1995, the North Sea oil platform, this is off the coast of Norway, it's called the Dropner platform. And I think it's actually natural gas, my bad, not oil. But nonetheless, large platform offshore. They actually had a downward facing laser that would measure the sea elevation and wave height. And they actually measured for the first time, so this was the first scientific measurement, a wave of 85 feet or 25.6 meters in height that was so large, and you can see this is the structure in the bottom right corner here, that it actually contacted the bottom of the superstructure above the scaffolding and caused minor damage. Well, at this point, having this measurement, having the corresponding damage to the structure, it was no longer possible to deny that these waves existed, and that it was just a question of, well, how common are they? I don't know if you have anything to
Well,
add there, Dan, but
yeah, I think part of the problem is not necessarily a disconnect between academia and industry. I think you know, scientists typically want to say, "Show me the evidence," right? And eyewitness accounts. You're using approximations. We're not out there with a ruler measuring how high a wave is. It's some level of approximation. And to be fair, sailors are pretty good at approximating distances and heights and stuff like that. But so the disconnect for that, I think, is just show me the evidence. And the other problem I think is that the ocean, or the Earth is 70% water. These could, they don't just form off the coast of one and go all the way across to another, and they can be picked up by buoys. They show up in very random spots, usually out in the middle of the ocean, usually not necessarily close to to land, where buoys may be able to pick them up. So, and as we start increasing our technology and putting out more deep sea buoys and stuff like that to create the measurements of the salinity and the temperature and the pressure and wave heights, I think that information is going to become much more prevalent.
excellent. Okay, thanks for adding that analysis there. Yeah, and I think part of the problem too was that we had these models that were actually very well studied and matched what we observed quite well. So even though we knew that Dropner was the first scientifically measured rogue wave, in the past, due to the factors that you identified, it's kind of like what is the actual scientific measurement and evidence. There was also that, but in addition, there was a close alignment of the existing theoretical models. So this is a paper from 1968, I believe, which basically goes over, what a basic wave model might look like. And this is establishing, you can see here on the right-hand side, this is a wave exceedance model, which is modeled as a exponential Rayleigh distribution. But you can see that there's not a nonlinear coupling. So when we talk about linear versus nonlinear models, What people need to understand, what we mean by that is that if we have inputs to a linear model, they are only interacting by addition and multiplication by constants. You could actually have something that is a higher order term that comes into the model, like an x squared or something potentially, but there's not like a multiplicative effect. That's really what we talk about linearity and nonlinearity in this context, what we mean. It's the difference between a multiplicative effect in the effects that go into the as inputs that then relate to the output. So we had these models that were very well studied and they fit really well the data. So that also adds to the friction of saying, well, hey, this is reported. It's more likely that it's a mistaken reading if our models have been so accurate. However, after Dropner, again, we had this measurement and there was puzzlement as to what caused this disagreement. Now, 2007, we had what's called the Andrea wave, which was also a sort of similar situation on a deep sea platform, but it had a sort of sensor grid versus just like a single sensor. And it was able to measure much more precisely with higher fidelity and with higher resolution what the actual wave size was, which in this case, I believe, again, this was like about an 18-meter wave. 18 to 20 meter wave, which is also massive when you think about it. And this is from the paper by Magnuson and Donnellan in 2017. And what they actually found from their analysis was that the encounter probability in any given point in the sea would be about 1 in 2,637. But for the so-called maximally steep and breaking, and I think those would be the ones that are something like more so in the range of like 90 to 100 feet we're talking about. It's about 1 in 133,000. So that does give you a sense of, how rare these events are. Their conclusion is that they're not that rare, but I think that's kind of in the context of what it means statistically. Dan, do you have any comment there in terms of that piece? We also have
Yes.
the recurrence period, but
Right. And so when we're talking about the linear theory, I mean, that's kind of, the paper you showed is going to be based off of Airy's wave theory, which, it's kind of it's a linearized description of gravity wave propagation, right? And it's on the surface of a homogeneous fluid. So it's, it has a certain assumptions and things like that. So the assumptions with the linear theory is that a small wave amplitude is relative to the wavelength and depth. And then the waves act independently is another assumption. And the last assumption is that there's boundary conditions applied at mean water level, not the actual wave surface. So that was like a disconnect there. When you start getting into the nonlinear wave theory, I don't know if you discussed that yet or if I should hold off on that.
no, go ahead. You
Um,
you will explain these equations better than I will.
so the nonlinear wave theory is based on Stokes waves. So while Airy was in 1841, Stokes was in 1847, and he kind of extended Airy's linear theory for nonlinear wave motion. So and it was correct up to third order and wave steepness. So Stokes theory accounts for um, wave ace the asymmetrical nature of waves, sharper crests with like flatter troughs, wave steepening as amplitude increases, and also a 15 to 20% height boost that makes align waves even more extreme. So it's the idea of these two theories being expanded upon and using that to identify these rogue waves.
Makes sense. And correct me if I'm wrong, I was just doing background research, but based on the existing research, it seems to be that there's some level of like a chaos or chaos theory effect here where these might not actually really be all that predictable. Like we can maybe predict them on and so for people that are listening, when we talk about chaos, we don't just mean like a crazy system where all this stuff is happening. What we mean is that it's a dynamical system where when you make a small change in input conditions, it can lead to a much larger change in output conditions. And practically what that means is that while we maybe can predict what the system will do probabilistically, it's not really possible to give a deterministic prediction. So, for example, if we had a certain C condition, a certain current, a certain bathymetry, I don't know, all the factors that influence wave formation, you wouldn't be able to say that a rogue wave would occur at a particular time. You might be able to describe an overall probability, but it's not like a predictable deterministic event. Correct me if I missed anything there or didn't explain that correctly, Dan.
No, no, you're absolutely right. Because when you talk about the like the factors, and you might go into some of these on your other slide, but like there's a linear, supposition of wave focusing. So you have waves traveling at different speeds that converge at one point. So therefore, that enlarges the one wave now. And then the other issue is it adds to their height all the way around. So then that's just pure area theory. And then the nonlinear stretching, which is bound harmonics, which is Stokes, which is when the waves get steep, they act differently because they stretch the crest higher and they compress the trough, making them flatter. And then there's dispersion. So even if you can account for the sea state and the speed of waves and things like that, how do you predict where they're going to intersect?
Right.
Because it's not like they're all going the speed limit on the highway. There's always that one jackass in the fast lane who's driving slower than everybody else. So the waves are very similar to that, like what's pushing them, whether it's wind, storms, things like that. And so you can predict models of like, hey, this could occur, but you're still only talking about percentages of uh, of accuracy or confidence level.
Yep. And I think the current research is maybe suggesting that these are more of a risk to ships and infrastructure than was previously thought, right?
Absolutely. And that's just because there's been no all evidence has been anecdotal eyewitness accounts. There's been no direct evidence. And like I said, as they've gotten to, you know, technology has advanced and we start looking, let's say, inward more towards, towards the earth, we start seeing some of these anomalies and stuff like that we have to start trying to see we can predict and try to, ensure safe transit of goods and personnel and in the matter.
Yeah, makes sense. Well, that's all I really had prepared. We could dive into if anyone has any points of discussion, we can open up the floor now. Any questions, or if we could maybe dive into any one of the aspects, whether that's kind of the history, um, maybe pull up one of the papers and dive deeper into the wave mechanics, whatever you guys want to do.
I would like to say that um, rogue waves are. I wouldn't necessarily define them as freak events that require special conditions. I would just say that it's basically ordinary wave physics aligning in an extraordinary way, if that makes sense.
Yeah, it does. And I think we really see that in this image here, which is, I'm glad I was able to find this included. Because two out of these three, if you see my screen, they are sort of like, particularly extreme and in the context of a higher sea state. But the one on the left is kind of maybe more representative of what the concept actually is, where you can see that there's this underlying sea state and then this sort of, to your point, forced or like randomly intersected peak wave pops out. And that's really what we're talking about when we say that it's like rogue, or they originally called it freak, but I don't think that's really used as much anymore.
And actually, if you want, take over a screen share real quick. I'll show
Yep,
you
go for it.
a quick video of. Um, so this is actually the aircraft carrier I was on, the USS Keokuk, and here is a storm-driven rogue wave. Now, remember, flight deck is 60 feet above water. Where this is being taken at the windows is roughly, call it about, I don't know, uh, probably about another 75 feet above where the flight deck is. So you're talking, 100, 125, 130 feet above the waterline for like, a normal sea level, let's say. And there's no sound in this. So,
And already the sea state in this is just insane.
yeah.
Like I can't even imagine what this would be like. Wow.
And there's a second one right behind it.
And that's kind of like maybe we could talk about that. There's like the Three Sisters effect
Yep.
on the Great Lakes. And correct me if I'm wrong, but that's one of the primary hypotheses as to what sunk the Edmund Fitzgerald, because it like ripped open these hatches and like basically because it in that case the ship just kind of it was underway and communicating, and then all of a sudden it just wasn't there anymore.
So for a ship at sea, when you're dealing with, high sea states or storms or everything else like that, you close all the watertight doors, and that's where the batten down the hatches comes in, and you try to ride it out. So if you're in a storm and you're knowing you're going to have high sea states, then you absolutely close all the watertight doors. You set condition throughout the ship. So not only the external ones, but you also set up some internal ones as well, because the idea is to, in the case that an external one fails, you still contain the flooding, doesn't run throughout the ship. So inside of a navy or inside of a ship, there's what we call knee knockers or bulkheads, which are um, oval shaped cutouts that you walk through. And then some of those cutouts will have a watertight door on them. And when you're in high sea states, you're basically closing, depending on how high it is and depending on the kind of ship you are and the captain's discretion, you would close all watertight doors to prevent any sort of uh, catastrophic flooding or what we call like rolling flooding, because once it starts at one place, if you don't stop it, it'll continue going on further down the ship and everything else. So not even just on an aircraft carrier, this includes all ships. And the idea is that if you don't know this is coming, and you probably have at least the watertight doors out, the external ones closed for the most part, but you may not have, a true sea state condition set. Someone could have left it open. Someone could be out having a cigarette. It could be any number of things, or it could hit high enough where doors that are usually closed closer to the waterline are left open higher up, or not even what we call dogged down all the way. It's only half dogged down, so it's not actually watertight, or even failed maintenance on the rubber seals and things like that. These are the things that can lead to flooding, and these are the things that can lead to anything else. So if the Evan Fitzgerald was not encountering a sea state or was not expected to see a sea state and gets hit with a set of three waves,
Yeah.
the first one's going to knock it sideways, and before it has a chance to correct itself, it gets hit again. Um, like the video you showed, if you notice that the wave came from behind, that's obviously a danger to begin with, but they also started turning, you know, um, to starboard, to the right side, and they actually took the wave at an angle, which is, I don't know if that's the best thing to do anyway. I mean, Tiny Captain could probably speak to it more than I could, but um, the idea is that you always want to be heading into the wave if you possibly can, or at least make yourself, like, you don't want to be broadside to a wave like that. And if they were broadside, then it would knock them. It would cause a list to start with, and before it could right itself, it got hit with another wave. It's just going to knock it back down further, and then the third wave could have been the end all be all of it.
Yeah, it makes sense. And that's the other thing I think with the Edmund Fitzgerald. I think people don't even really understand. And I forget where I read this, but there was some article I was reading where I was discussing it. And it was like the conditions that you'll see on the Great Lakes are, every bit as dangerous and extreme as what you would see on the open ocean, right? I mean, you have those storms that come down over the lakes out of Canada, and they're, more than large enough and deep enough to produce massive waves and gale strength sort of sea states. Is I don't know if that's correct. I'm kind of mixing up, I think, the Beaufort wind scale and the sea state there, but I think you know what I mean.
Yeah. Well, and you've talked about, I mean, like Lake Superior is 1,300 feet deep, right? And Lake Erie is the shallowest, and it's 200 feet deep. So who's to say, these are deep lakes with, open the weather patterns. Anyone who lives in the Northeast understands what lake effect snow is and what that causes and what a nor'easter does. So it would not surprise me that's sort of causation or correlation was made about what it would be like on the ocean. I can't speak to it because I've never really sailed the Great Lakes, but I have sailed the Pacific and I have sailed the Indian Ocean, and it's awe-inspiring. So you feel very small very quickly.
So, what was the most dangerous area of sea that you transited? The off the Cape of Africa in the Southern Ocean? Did you cross the Drake Passage? My understanding is that, like,
No.
okay,
We were stationed in San Diego, so we did a what we call a Westpac deployment, which was um, to off the coast of North Korea and Japan, and that's what we call AOR. That was interesting enough because as much as it makes sense to see it is kind of unique, but to be out on a flight deck in the middle of the ocean, not seeing any land, and to have it be a snow squall is just kind of weird to think about.
Yeah, that is weird to think about.
But I mean, it makes perfect sense when you think about like why wouldn't there be squalls on the ocean if there's squalls on the land kind of mentality.
Right.
But to actually see it, it was like I never thought I'd see this. And to be high up, if you're higher up on the Japanese island chain, I mean, you're getting closer to Siberia. There's ice and things like that up there, so that's something to kind of keep in mind. But to be honest, I think the biggest sea states that we really hit was going uh, from Hobart, Tasmania, up to Hawaii. I think would be some of the more spicier sea states that we saw, just because it's literally in the middle of the Pacific.
And how long would you go without seeing any land on a transit like that? I don't know how
So
fast
so
these aircraft carriers are, but
so we go 30 knots, and the difference is the Kitty Hawk was a diesel powered one, not a nuke. So we had to take fuel every 3 to 5 days. So it's not like we had a nuclear reactor that we could just run off of and just had to get fueled with like jet fuel. So the Navy tradition or U.S. Navy tradition is that if you're at sea for more than 30 days, you get 2 beers. So some of the stretches I've done were uh, anywhere from 20 to 28 days. I think we had about 3 or 4 of those stretches. Um, Never did get my beers. Um, but we're doing 30 knots, and that's the publicly um, realized speed that's published. Um, so if you're averaging 30 knots and you're going 24 hours a day, I mean, an aircraft carrier, when it's trying to do training or it's doing combat operations or things like that, it does circles. But if you're in a rush to get somewhere, you're not necessarily putting planes up in the air if you don't need to, or you're just putting a few planes up in the air. So you always have to be turned into wind to launch the planes. So it takes us 7 days to get from San Diego to Hawaii because we're constantly going around in circles. But it would take us 20 days to get to Japan from there because we're constantly doing because we're doing more circles because now we're doing patrols because of Russian bears and other air adversarial air assets that are trying to find us or to document where we are and things like that.
so when you say a Russian bear, just for the sake of the people in the chat, we're talking about the Tupolev based like
95, right?
yeah. So it's a large plane, right? Not like an actual bear.
Yeah. Yeah, no, yeah. It's a large bomber. It has 4 engines with counter-rotating propellers. It's the equivalent of it's a turboprop version of a B-52.
Okay, gotcha. Yeah, so that's all I really had. I didn't have anything else prepared. I see Jaya is off mute. I don't know if you wanted to add anything.
Well, so I've been
Or
trying to get my husband to come join in because he just got home and he was also in the Navy. Um, but he did answer one of my questions. So I asked him what his highest sea state was, and he said 8.
Okay.
He
Oh,
said
he
it.
was in some spicy stuff.
Oh yeah, yeah. It was at the edge of a typhoon near Australia.
What ship was he on?
Which one was that? The Chosen or the?
It was on my first appointment with the
It was
Chosen.
on the USS Chosen.
No kidding. Okay. So yeah, so he was at the one it was probably around the 1998 in December timeframe. Um,
No, no.
or no, I'm sorry, because the Kitty Hawk that was the wave I showed was that hurricane. And I just talk about battle groups because different battle groups are in different places. So like for one of my battle groups, we had the Cowpens, the Vincennes, and a couple other boats to think about really hard. Not on a Friday night to to come up with, but the funny thing is, like the Vincennes was not allowed in the Arabian Gulf where we were going because they had that unfortunate airliner incident. So they were no longer allowed in the Arabian Gulf. So they had other tasking to do, but they were still part of our battle group. So there's always different ones that we're going with and stuff like that. And I always don't know the rest of the ships in Belgium because not all of them had crypto gear or were part of our network or in part of like what we call HFDF and stuff like that. That's the only reason why I asked. But no, the Chosen was a good ship actually. And I knew somebody on it not too long ago.
Yeah.
What's it?
This was
It's a Tycho.
so he had deployed. It was like, it wasn't that long before I actually met him. So like 2013,
What, my deployment?
Yeah.
Was 2014.
2014.
2014. Okay.
That first one.
Yeah. Yeah, he wasn't actually
Yeah, I'm a lot older
on
than
the
he is.
Chosen. He just he went on deployment with them, but he wasn't actually on that ship. He was on the Port Royal.
Yeah.
TAD.
Oh yeah. We call it temporary assigned duty.
Yeah, that's what he just.
You get voluntold. Voluntold.
Yeah.
Yeah, it was a Ticonderoga class cruiser. I hate to see those go. I love those things.
Yeah, he was. The Port Royal, I believe, is the one that's being decommissioned, right?
It already is.
There's a lot of being decommissioned, but yeah.
Oh, it is. It's already decommissioned, actually.
Well,
That's pretty
the
crazy.
JeaKat got stripped and towed around South America and was dropped off in Texas to be turned into razor blades for $1.
Oh my gosh.
$13 billion to build it, but hey, let's sell it for $1 because the JeaKat was originally laid in 56 was the keel was laid. I mean, she has a weird history to begin with her and the USS Constitution or Constellation. Yeah, she was decommed in, what was it? Yeah, she was laid in 56. She decommed in 2009, and then they struck her from the records in 2017.
Wow.
So the boat was the boat was laid. The keel of the boat was laid that I served on was laid 2 years after my mother was born. So go figure. Cutting edge naval technology, I tell you.
Yeah, Mordwand, you actually had said that you. Shoot, what did you say? It was like, there's just like a disconnect there between the, the these things exist, and then everyone's like, oh well, we can't, like, I didn't see it with my own eyes, type of thing. But, I mean, that's what it seems like anyway. But, yeah, those. I mean, there are videos now, like, all over YouTube, and I think the craziest one was when the wave came from behind, as that's scary to begin with, and then it was like full of like workers. 'Cause it was like I think it was a fishing vessel or something like that, and it was pretty insane. Oh, and actually, I did see one that like rolled. It was a smaller boat though, and it just like completely rolled like 360.
And when the wave comes from behind, you end up surfing it, and when you surf it, you don't have any control. It's like you just have to wait for it to pass before you can start doing anything else. Because not so much on an aircraft here, but depending on where you crest the wave and stuff like that, like you lose propulsion because your
Oh,
screws
wow.
your propellers are out of the water. Because the wave has literally picked you up and it's now throwing you forward. So you're literally debris at that point. You're along for the ride.
That's the thing where I feel like our daily experience, we can't even really comprehend this sort of scale. And I feel like even though there's like a surreal aspect to it, even when you're on the ship, I imagine there's a certain disconnect from like the scale of what's happening to some extent. Like the thought of like I think about like surfing or like body surfing, and then imagining a freaking 200-foot long, 50-foot wide ship doing that is just, and that's not even that big of a ship. That's just mind blowing to me.
Yeah, I mean it's pretty. I mean you're talking about a 300-foot ship is about what the a Tycho is, right? So like the Oiler was it's a 470-foot ship, and the Chosin was the Ticonderoga class is about 600 feet, almost 550 feet. So I mean that's a decent ship. Um, but someone like the Kitty Hawk you're talking about a little bit longer than that. I mean, it's over 1,000 feet, twice the length.
And that can surf a wave, theoretic.
It's
Wow.
big enough.
Yeah. Just puts our tiny human bodies to scale.
And the
We're just
interesting thing, a part of it is like when you're on the ship, like you have everything contained in the ships. I mean, especially on aircraft carrier. I spent some time on the cow pens um, for a few weeks because somebody had appendicitis. We're kind of in the middle of the ocean. They flew him over to the carrier for a surgery because we have operating room on the carrier, and so obviously he was on uh, light duty afterwards for quite some time. So I went and filled in on the cow pens for a few weeks, and the difference in the style of ships and the size of the ship is like crazy. Like there's an escalator. Granted, it never worked, but there's an escalator in the aircraft carrier that takes you from the O3 level, which is just below the flight deck, down to the second deck. So it's a 5-story escalator that takes you down to the same deck where the galley, medical, and everything else is at. So when you're on a ship that big, yes, it's moving. And I mean, we used to uh, um, haze some of the newcomers who came to the ship because they think an aircraft carrier doesn't move, and we would hang a stapler from a string in the roof, and we would let it circle, and as we took rolls and in dips and dives, and when someone lost their lunch, we would just mark on the floor, where that stapler was, so we can figure out what it is. But the testing for an aircraft carrier has to be that they can take 15-degree lists for an extended amount of time without rolling.
Wow. That's wild.
Smaller boats, I'm not sure what the list is, but I'm sure it's probably kind of something comparable. And I will say that the you feel the waves on that little one a hell of a lot more than you do on aircraft carrier. I mean, it makes sense that it's the case, but like you need a seatbelt in your rack on the small ship to keep you in your rack on some of those sea states. I mean, otherwise you're gonna end up on the floor.
Hey, so I'm going to. Okay, again, anybody, if you have questions, just go ahead and tag me, and I'll give you the floor. So we're gonna give Michelle the floor because she has a question.
So I was wondering if from the movie, I think it's considered a true story. The movie Maverick with Gerard Butler, um, or derived from a true story. And he's a surfer from like Australia or whatever. And remember I don't know, has anybody watched that movie?
So you're talking about Chasing Mavericks, I think.
Is that
And
what?
yeah, it's Mavericks um is a known surf break. Um
Okay. Of
in
like
in
really big
California.
waves.
Yeah. For the West
Okay.
Coast, it's one of the bigger ones they hit, that and trestles. I personally don't surf those because I don't belong in the waves like that on a surfboard. But yeah.
Yeah. So I was just wondering if the wave that he surfed in that movie would be considered a rogue wave.
Um
Because that wave was, I don't know, it looked at least 100 feet tall.
So that's a great question. I think that it depends. But I think that typically, like, there are cases here where, like, I pointed out like a lighthouse which was hit by a wave that was, considered maybe a rogue wave for its size. But I think in areas where those sorts of waves often occur, like the Mavericks is one spot, but there's another spot off the coast of Portugal. I think it's like Navarre, Portugal, which
Yep.
is even more extreme. I don't think they're considered rogue waves because they kind of come in sets and they're predictable in the sense that they're being driven by like an offshore swell hitting an area where, and again, correct me if I'm wrong here, Dan, but I think this is how it works, where like the ocean floor suddenly comes together in a way that it forces the wave up a channel and creates a much larger wave. So even if it would maybe meet the technical definition of being twice as high as the significant wave height, for that reason it might be different. But I'm not exactly sure, but I think that's kind of those would typically be excluded for that reason.
Yeah, because they're seasonal. Because Navarre is seasonal, North Shore in Hawaii is seasonal. Mavericks generally has pretty decent waves year round, but it is seasonal on when it gets the really big ones. And again, it could be storm driven, it could be swell driven. There's any number of variables that kind of go into it. But generally speaking, we don't necessarily consider those rogue waves because they're kind of coming on the land. So there's other variables that kind of go into it. In the middle of the ocean, you don't have that the ocean floor affecting when a wave crashes or its shape.
Yeah, that makes sense.
Okay, cool. Makes sense.
Good question, though. That was a really good question. I'm glad we got that one because that was something I'd been thinking about bringing up in the presentation. So,
I mean, but those are those are the known like those waves are especially like like things like Navarre. There's also one where they held the Olympics. In French Polynesia starts with a T. I can never remember how to pronounce it. Um, those waves are huge, but they're predictable and seasonal and stuff like that. But they usually have to be towed onto the wave by a jet ski because they're moving so fast. You can't paddle onto them. They're difficult to paddle onto. So usually you have to have a jet ski to throw, to kind of pull you along so you can catch the wave, and then the jet ski bails.
That's pretty intense. That's crazy.
Mavericks doesn't classify as that by any means, or trestles, but like Navarre especially, and some of the other ones are the bigger waves. Usually the way to guarantee to kind of at least be able to catch them is going to be by jet ski. But it was based on a true story, and actually the 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 person it's based off is Jay Moriarty. Um, he actually ends up dying at age 22 by free diving in the Maldives, not even surfing. So talk about strange.
I knew it was going to be the biggest wave I ever rode, and I knew what I was getting myself into. I've been preparing for it for years. It's just the eighth wonder of the world. When it comes to big waves, I found the holy grail. Sometimes I look at it and go, it's not that big at all, and then other
But if you want to learn, I mean, surfers are the ones who can like what they call reading the waves to try to identify sets and stuff like that. We don't necessarily have sets like the Three Sisters sets that you referred to, Morty. That's more in line with. It's not just that one wave; it's going to be multiple waves. Yeah, there you go. I didn't see you were playing that. Those guys are nuts, personally.
God, I was on mute. I'm sorry. I was gonna say that's kind of the classic one, but yeah, to your point, those things like the surfers aren't just like randomly encountering those waves. They know that there's a certain time of year, a certain swell off the coast, and they can go to this spot and get a particular wave. Whereas like a rogue wave, well, you hope you can avoid it, but it really could just pop up randomly in the middle of the ocean without any sort of forcing. The other thing, one of the things to talk about is that there does seem to be a effect of currents potentially. And new research is suggesting that on the Pacific coast of South Africa, there's a particularly strong current, and it seems to be that in that area, rogue waves are particularly common. So perhaps as we learn more about the ocean, and that's the thing, right? We know so little about the ocean for how big it is compared to the land. Um, Really, I mean, we're learning all the time, right? We do have some models and stuff, but perhaps we'll be able to better identify, risk zones, or we can't ever predict that a wave will occur probably because of the chaotic nature of the interactions that you talked about, Dan. But perhaps we could, put a red zone on the map that, at this time it's likely that a wave is going to occur.
Well, I mean, if you have enough data, you can start plotting, right? And start saying areas that are more prone to them than say aren't, but you're still not going to uh, predict all of them because you're still going to have outliers. But the physics involved in it between, the, all the different variables that go into it, like wave speed and the convergence point and all these other parts of it that go into it, they all have to be right. And like you said, the chaotic nature, if any of those changes by a percentage point, and you won't have one.
Yeah, it makes sense.
But no, that was a great question. That is,
Yeah,
as
excellent
a
question.
surfer, as a surfer, it's something I enjoy talking about too, because I don't know, I was always on the water. Let's put it that way. So joining the Navy just seemed to be the thing to do.
Yeah, makes sense. I paradoxically, I have a bigger fear of the water. I've spent a lot of time in the ocean near shore in Florida. Um, but like things like scuba and whitewater rafting, especially like wreck diving and cave diving, it just freaks me out. Diving in a confined space, that's like,
Upstairs.
I love wreck diving, cave diving. You will never catch me in. I did one overhead once first as part of like as a training. So it's like I was looking at getting my cave diving certification for my dive license, and the the first time I went in, it's like, you're hooked to somebody, they have their hands on you the whole time because you're going to get into zero visibility. There's no place to run. If you run out of air, you have, anything else. Uh, it's like NASA redundancy for those divers. And the first time I went in, I was like, nope, no, we're done. I'm avoiding this now. I'm not comfortable. Forget it. I'm never doing this again. Wreck diving, different story, but no, forget it.
So I'm wondering, I didn't see anywhere on there, but when did they actually start? Like, what year did they actually like officially start studying?
so it looks like that goes back pretty far. And I imagine there were some like individual scientists and naturalists earlier on that had maybe documented and studied this phenomena in like early encyclopedias and stuff. But it seems like the genesis of studying it's in modern scientific context is around the 60s. Um, and I think that it didn't really generate all that much interest until the Dropner wave, from what I can understand. But that's just my lay reading of the literature. I'm obviously not an oceanographer or wave mechanics guy. So it seems like though around the 60s it started to accelerate more in terms of getting a more formal and serious treatment. And then in the last 2 decades, and especially in the last decade, it's really exploded in terms of like the amount of research that's being done.
Yeah, it seems like it became of interest, but the idea is like, how do you find them in, vast oceans to be able to measure them? So that was always the hiccup. So, it's basically just put instruments wherever you possibly can and hope you get lucky kind of mentality. And they sound like they did in 95 and a few other ones too.
Yeah, 100%. There was recently too, I think there was a research ship that recently just recorded a wave. Like there was I forget, I think it was in the Southern Ocean and there was a research ship, yeah.
But the interesting part about the foundational things, very Aries and Stokes, is that these same theories and models are the ones that are used for building ships. So that they know what the ship's motion is going to be like, heave and pitch and roll. Um, they're gonna they you can calculate hull speed and hull loads. You can also use it for designing breakwaters and harbors and wave transformation in shallow water, like how the sea floor as you get closer to land affects waves and things like that. So that's those two kind of base that and it got expanded upon by so like more of a oceanography type of mentality. So they applied the same foundational theories and then built theories off of those. I mean, even oil platforms were all based off the same thing, lighthouses and stuff.
So does anybody
Yeah.
know what the largest recorded, obviously, because that's, you, I don't know, anything that's not recorded is just considered hearsay. But what's the largest recorded, like, non-tsunami wave?
I want to say it's around 100 feet, but like I said, there was that example of the lighthouse, which pointed to like a 200-foot wave. But in terms of like what's been officially recorded with scientific instruments, I want to say that the one of the more recent ones is, I think there's some during hurricanes, they've recorded some with buoys that are in the 100 to 130-foot range, but I don't know of any higher than that. Dan, do you have anything to add there?
Just the one that I mentioned from Tasmania, from Tasman Sea, that one. Um, that was in 1998. That was a 120 foot. That's the only one that, and again, that was an approximation from a rescue helicopter. So I wouldn't necessarily count that as a measurement. Although, me personally, I would accept that as evidence because they're pretty good at estimating those kind of things.
Yeah.
But if
All
you're
right.
ever in Europe and you're on the Iberian Peninsula, I definitely recommend if the season to go to Navarre and see
See the
the
waves.
breaks
Yeah.
going. Yeah, see the breaks there because it's you feel it in your chest. Let's put it that way.
Yeah, it's pretty wild. Yeah, I've been on the Highway 1 and I've seen some, areas where there were some pretty big swells off the coast, but that's kind of it. And that was in the
Yeah.
summer, so they weren't that big.
I found myself in some overheads and I paddled back in really quickly because I've realized I was out of my depth and uh, I do not the ocean is not something that I'm going to test. Let's put it that way. I
Yeah.
like breathing. But yeah, as far as measurements go, I mean, coastal waves in Navarre can easily reach 90 feet to 100 feet. Hurricane waves and buoys can measure quite a bit as well. Uh, to be honest, I don't think we have an exact measurement before the 1995 one where it was actually measured.
Likewise, I think it was mostly inferred based on like damage to structures and triangulation and stuff. But it is interesting that from what I can read, that lighthouse one seems to be an exceptional anomaly. But it seems like from all of the reports that I looked at, somewhere around 120 feet was the maximum one that's ever been reported as well. So perhaps that's like, minus like a 1 in a million, type event, that's kind of the expected maximum height.
What's really interesting though, I I just remembered this, but one of the theories of like the ships and planes and stuff disappearing in the Bermuda Triangle was rogue waves.
Interesting.
Yeah. I don't know how accurate that is because, I mean, if I were, you know, an oceanographer or something and somebody was like creating a research team for rogue wave studying, I mean, that's probably one of the first places I would go just to see, like, just to see because there's all this myth behind this one place, and I mean, you could just try it.
Well, I think that's part of the disconnect too between academia and let's say the industry, because sailors are known for telling tales kind of mentality, right? The maps that say there be dragons here, or sea monsters that we look back now, you could equate to uh, someone in the seal, and in the age of sail, who's been you know rationing food and water, and all of a sudden, they see a manatee and think it's a mermaid. There's different stories that, as we look at them in a present view, as opposed to 500 years ago or 600 years ago, what it actually looked like. And I think it's interesting, though. I think it's one of those things where if there's a myth behind a certain excuse me, it's behind a certain area like the Bermuda Triangle, I think that does beg some sort of research. The idea is that, like, I experienced one wave, on two different deployments, and that's over a year at sea. And some sailors have spent countless years at sea and never see a single one. So go figure.
Yeah. There's another interesting aspect of this, which is the survivorship bias, right?
Yeah.
In that, in the past, especially, I think we're seeing a lot more reports now, not because there's an increase in frequency, but because um, when it was in the age of sail and you were in a wooden ship, if you got hit with a 100-foot wave, you probably weren't coming home.
Right. Yeah, they weren't exactly watertight with, new technology of watertight doors and ship design. It's the roll back over. And we have stations and communications that allow us to rescue those people and stuff like that now. So yeah, it's definitely, as the definitions change and as technology has increased, I think it's going to become, they're not more prevalent, but they become more studied, and we start seeing that they're not necessarily such a unique environment.
Yeah.
I mean, they are unique, but not necessarily 1 in 10,000 years kind of thing. It's more of a, well, maybe 1 in 5 years in this area or something like that. But again, the
And
predictability
with
of it is difficult.
right, and with so many ships on the ocean too, like
Oh, yeah.
it becomes more and more likely to encounter them as well.
All I know is if I see a wall of water coming from me, it's going to be like, well, it's been fun.
Yeah, exactly. Imagine being on like a sailboat or something, like these,
Oh,
crazy people
Jesus.
that sail around the, Drake's Passage, or what are the worst seas in the world? I mean, Drake's Passage is one,
Drakes.
right? And then
Drakes.
what is the bay off of the coast of France? Bay of Biscay, is that the one?
Yeah. I think Drake's is still the worst on the ocean. I mean, it's called the Roaring Forties for a reason, Rory, because it's such a narrow span between the peninsula of Antarctica and the tip of South America that it's just, I don't know. It just seems like, I mean, any of the capes are going to be crazy, but that right there, just, I mean, I haven't actually seen it, but talking to people who have gone through it, just they say it's like, yeah, you think you're humble sitting in a hurricane in the Pacific, try going through Drake's on a good day, forget it on a bad day.
Right.
But sailors doing that, solo sailing in a boat, yeah, you're insane. Like like the woman who did the Antarctic Cup solo, Lisa, what's her name? Yeah, now I have to look it up because it's going to annoy me. I don't know if I spell Antarctica right. Lisa Blair. She did it solo, and when you're, let's see, I, I or how I am on Twitter. I have these on my Twitter replies. I don't feel like I'm looking for them, but she had a 72-foot oyster yacht. Oh, sorry, that was the catharsis. Uh, Lisa Blair's was, I think it was her boat or yacht. Excuse me. What's the name of her? Oh, here we go. It is a fiberglass hull, 15 meters. So she did it solo around Antarctica in 92 days. So imagine sailing solo for 92 days, sleeping in 4-hour shifts, and
Oh my
depending
God.
on weather, might
Yeah.
not be getting sleep for a while.
Jeez. That's intense. What about the people that like they have a rope and they like jump off the back of their sailboat when they're doing these solo trips? And then if the rope comes unattached, you're just gonna watch that boat sail away from you.
Pretty
That's
much.
always just yeah.
Yeah, I don't know. I mean, you're putting a lot of faith into a knot. That's I mean, I rock climb, so maybe I put a lot of faith into knots too, but I mean, it's still I don't know. The ocean is not someplace that I would do something like that with. Calm day, maybe sails, uh, like no sails out, no anything else, and you're just sitting in a nice calm thing, like jump off of the rope and you can pull yourself back through so you can make up the drift. Yeah, maybe. But that's about it. It's like the
So,
videos of the aircraft carriers who did swim days with cargo nets off the hangar elevators.
Oh
And
my
meanwhile, you
gosh.
have people on shark watch with guns. So thanks, but no thanks. I think I'll pass on that and work that day.
Yeah. Oh man, that's something else. Shubal, I saw you just showed up. I don't know if you have anything to add on you know a lot about nautical history, so if you have anything to add on the historic rogue waves front before we wrap up here.
No, the only thing is they were kind of mythical until you get better observations. So if you have a logbook entry from, Captain Blythe, that's one thing. But now there's satellite data where they can map these things, and everyone's got their GoPro, so they can, say, yeah, it really is there. So, I- I just I didn't know if there was some sort of denial or fascination or weird conspiracy theories on how they happen. Sees how I missed it all.
Oh yeah, we were just talking about a little bit of that aspect, but like how the Dropner wave off the oil platform off the Norwegian coast was kind of the first major observation, and how you know maybe part of the reason why it hadn't been accepted in the past was that it was such a it had never really been measured before with any sort of scientific precision. So even if there was reports about it, it could easily just be described as a mistaken report, thinking a 60-foot wave is 90 feet or whatever.
Yeah, yeah,
Which,
subjective. Yeah, subjective estimation while in panic mode. It was bigger than big.
yeah.
But now, yeah, now everyone's got dash cam, so they can get it's like, yeah, he wasn't kidding.
Well, that's all I think we had planned. So thanks so much for hosting, Jaya. This was really great. And Dan, it was instrumental having you here. So thank you so much for
No, thanks
joining
for
as
having
well.
me on. I appreciate it. I always enjoy talking about this kind of stuff, and not to mention it was really interesting because when you said you were doing this, it was like I immediately remembered that I remember reading an article about science has finally identified what could possibly be what's contributing to these a month ago. I'm like, oh, this is perfect.
Yeah, I just saw a video on YouTube that's a good summary as well, and it kind of described the same thing in the current state of research. That was kind of the genesis of why I thought up this as a topic. So it worked out well.
I imagine the big advent to catching these things is now there's so much buoy data.
Right, yeah,
Yeah,
that's the
and
other thing too.
that and the buoys now have satcoms and stuff like that, so they can relay information. So That's always beneficial.
Yeah, full service sensor, weather sensor, sea height sensor, all this good shit. So you could see the wave frequency leading up to it, then the spike, which is also what they use for the tsunami warnings. They can map the wave front of a tsunami with
Right.
that same buoy array.
Yeah, part of that is just logbooks.
Which is kind of extra hard if they're using satellite telemetry, because satellites are fake.
So let's just, if anybody else has any questions, now's the time. Just ask your question, and then I think if nobody has any questions, then we can just thank you guys for this. I would like to open to anybody if you have something scientific, regardless of if it's astronomy or not. I would like to talk about it. So I'm trying to get more, bring in more just all around science into the channel. So if you have any ideas or anything, just just tell me.
We should really try to get maybe get Jay Ace to come in sometime. He was just talking to me in DMs about those organic compounds that they recently found on Mars. That would probably make a good episode. But I don't, that's so far out of my wheelhouse that I wouldn't really have much to contribute.
Yeah, I mean that actually would, and I would also like to have another get together about where Three Eye Atlas is right now, and just a little update
I
about that. So
I was told probes are coming, but I remain unfortunately unprobed, and I feel cheated.
Yeah, I had some ideas. I mean, I had a bunch of ideas that I was looking at for doing for videos and stuff like that, but video content, it's more difficult to put together. So, I can definitely share some ideas with you, Jed, and see if there's anything there that sparks your interest.
yeah, sure. Just share it if it's in a if I already have a channel for it, like if it's earth based or if it has to do with it. So earth based, it's not just like, I think originally people thought it was just for posting about like Rubin, for example, because that's an earth based telescope, but it's really for anything, any type of earth based science. Okay, and that, I mean, obviously this is included in that, but yeah, just DM or put into any of the channels, and I'll take a look at all of it. And Mordwan, if you could just, all the stuff that you sent to me earlier, if you could just share that in the streaming text channel, that way anybody who wants to
Sure.
read about it
Yeah.
can come back and read about it.
Sure thing.
Enjoyed tonight.
I did too. Now I got to get started on my harp videos.
Nice. Oh, that'll be a good one.
Yeah, it's going to be 3 parts because there's so much stupidity around the whole topic.
So earlier I was talking to I think Shuba was there for this. I was talking to the Flirps at Riggs about GPS, and there was contention if GPS could penetrate through thousands of feet of bedrock to the bottom of the Grand Canyon from towers. And I was like, guys, no. Like, that's
Were they getting it
Well-
mixed up with LiDAR?
yeah,
Yeah.
well, Harp posted this thing about like very low frequency
Jesus
radio
Christ.
waves, and I'm like, that's not what GPS uses. And he's like, well, I'm not even
No.
talking about GPS. And I'm like, well, you brought it up in a convo about GPS. And then he's like, well, how do you know the signals aren't doing this? And I'm like, okay, so you literally were just talking about GPS. Like, I don't know if that's just a case of like mental impairment or if he's just that bad faith.
Yes.
It's really hard to tell. Yes.
Well,
They
yes to
they
both.
do they do seem to get those things kind of mixed up. Like I'm I'm friends with one who, like, we talk normally, but still when that kind of stuff comes up, I can tell he just has in his brain a certain way that these things work, and they do seem to, I don't know, it's a weird mix of them thinking that in some ways they're all the same, but then in other ways they're like way different than they really are. I know
Well,
that
and
made no sense, but
and radio as a whole is just something that, and radar and just the city EM spectrum as a whole is something that they seem to have problems with, because like if you're talking about, like medium frequency down, so you're talking about, very low frequency and low frequency and medium frequency. I'm like, this is like AM radio. This is like uh,
Mm.
communications to submarines while they're underwater and stuff like that. Like there's ground that follows the curvature of the earth. They don't, it's not line of sight. And then you have very small band, which is HF, which reflects off the ionosphere. And then everything above that, and I'm speaking in generalizations, there's a bunch of variables that goes into this, but those above that pass through the ionosphere. And those lower frequencies are absorbed by the ionosphere. And it's like, this is tested every day to provide, information and predictions and models for radio users, whether it's military, civilian, commercial, it doesn't matter. But just their understanding of radio as a whole is crazy. But actually, Morty, I don't know if I sent it to you. I found a very, very interesting um, paper that was done. So instead of just using GNSS uh, sites to, you know, to test the ionosphere and stuff like that, because they actually use they use two different frequencies that are for, like, they're into GPS ranges and stuff like that. So the lower frequency takes longer, and they use that to
Right, right.
identify the different methodology of the density of the ionosphere and the polarization, or the density of the
Yeah,
plasma and stuff like.
it's super cool. Yeah, they're using the GPS signals now and from the different GNS satellites to model the electron density and magnetic weather patterns of the ionosphere. It's pretty
I
cool.
got one better for you though. A
Okay.
paper used a bunch of Android phones to do the exact same thing. So basically, instead of being beholden to these individual brick and mortar sites throughout the world to measure them, they're using cell phones and a GPS on those. So in places where we don't necessarily have a lot of coverage, like say, somewhere around like say Africa or the Middle East or something like that, they're using cell phones to measure it. I'll have to send the paper over for you. It's really
Oh,
interesting
wow.
read as far as how to do that, because it's the same premise, but they're using cell phones to do it.
That's pretty cool.
Well, there's continuously operating receivers all over the globe. I mean, tens of thousands of these things, and all that data is pooled either daily or biweekly at like the Scripps SOPAC, the Orbital and Permanent Array Center. So I would think, and one thing I've noticed in the past couple decades with precise GPS is the improvement in ionospheric modeling. As you pointed out, they use dual frequency, which even the Navy transit satellites use dual frequency for that same reason. And I've noticed software and integer resolution of the carrier wave has gotten better and better and better. And I from the accumulation of decades of data and modeling. So when you say using all these cell phones, I thought maybe they're talking about just cell phone communication, direct satellite cell phone communication.
Yeah. All right. Well, I got to drop off. I got to eat and then
Yep.
wind down. But
I just sent that
it's
paper
great
over to you.
great talking to y'all. Cool. Thanks. Appreciate it. Catch you guys later.
Cool.
Bye.
Thanks, guys.
I'm sorry I missed out on the lion's share of that.
do better next time. Show up on time. What's wrong with you?
Okay, so
All
I'm
right,
gonna
guys. Good night.
yeah, I'm
Gonna go.
ending the event now, but yes, thank you guys for coming out, and by Monday this will be edited and posted, so y'all get
Thank
notifications.
you. Thank you, Jay. And Shoe Bill, I was just kidding. You know that, right?
Yes, I did. I could tell almost immediately.
Okay. Good, good, good. All right, guys. Bye.
Thanks for coming.
Bye.
Good night.